Hi everyone, today's lesson is about the limit of a function. I'm going to discuss four things. The first one is the significance of limit of a function. Second is the definition, and then I'm going to give you five examples about limit of a function using table of values and graph of a function. In this lesson, you need to be able to illustrate the limit of a function using a table of values and the graph of the function. Now, you might be wondering, why do we need to study limit of a function? If you want to become an engineer someday, this is going to help you analyze structural stability, stress, and load capacities. For instance, engineers use limits to determine the maximum force a structure can withstand before failure. So, say for example, you're a civil engineer, you're going to build a bridge. You need to have a good and a strong foundational knowledge about limit of a function. Also, if you want to become an economist or financial analyst, you will be using this one. Limits are used to model behavior as certain factors approach a critical threshold, like marginal cost and benefit analysis, or predicting market trends as variables approach certain values. So, definitely, limit of a function has a real life application. Now, let's go to the definition of limit of a function. Consider a function f of a single variable x. Now consider a constant c which the variable will approach. Now that c may or may not be the part of the domain of f. The limit to be denoted by L is the unique real value of f of x. Will approaches x approaches c. In symbols, to write this process as the limit of f of x as c or as x approaches c, which is equal to L. Okay, so let's illustrate first this limit of a function. Now here we have a function 1 plus 3x, and as you can see, we have here a table, and the x values we have are 0, 1.9, 1.999, and 1.999. And then we have also 2.001, 2.01, 2.5, and 3. And you might be wondering, why did we use these numbers? Now, take note that x is the independent variable here. We can substitute any number to x, but I specifically, or we specifically, pick these numbers, especially this 1.9, 1.999, and 1.99, because these numbers are approaching number 2. So let's say I put the number 2 here in the middle, right? So these numbers are approaching number 2. Now imagine a number line. So this number is 3, 2.5, 2.01, and then 2.001. These numbers or x values are approaching number 2. So our objective is, what is the limit of those numbers? As the numbers from the left, 0, 1.9, 1.999, they are approaching 2, and the numbers from the right side, they are approaching number 2. What will be the equivalent y value? What will be the function of 1 plus 3x as x approaches 2? Okay, so if you have a calculator, you can do the computation, substitute 0 to x, 1.9, etc., etc. You can pause the video if you want. Alright, so here we go. Let's see the y values from the left and the right at the same time. Okay, so if x equals 0, obviously you plugged in that 0 to x. That's 3 times 0 is 0, plus 1 is equal to 1. So that's 1. We plugged in 1.9 to x, that would be 6.7. And then that would be 6.97, and then 6.997. On the right side, if we plug in 10, or 3 rather, that's going to be 10, 2.5, 8.5, 2.01, 7.03, 2.001, that's 7.003, and as you can see, it's approaching a certain y value. And if you think that is 7, you are absolutely correct. So here the answer is 7. It might not be clear using table of values. Let's look at the graphical representation of 1 plus 3x. All right, so here, our answer earlier was 7. It's right here. Okay, so as x values on this side of the graph approaches positive 2 of x, right? And then as x to the this side of the graph is approaching that positive 2 value of x, that's gonna approach this 7, which is the y value. So that's how we looked at or consider the limit of a function graphically. Now let me give you examples here. So find the limit of absolute value of x as x approaches negative 1. And again, here what we need to do is just to simply use x values that are approaching negative 1. So I'm going to put negative 1 here in the middle. So these values are approaching negative 1. Just imagine a number line and then you put those numbers. You pick numbers, any number. But those numbers should be closer and closer and closer to negative 1. And you might be wondering, why not just plug in negative 1? Well, in some cases you might do that, but in some cases you can't do that. So I will give you example like that later on. Now here, this is easy. Absolute value of x, meaning whatever value of x there, absolute value of that will always be positive. So which means that the absolute value of negative 2 is just positive 2. Absolute value of 1.5 is just 1.5, etc., etc. Now you look at all the values here at the bottom. They are approaching a certain number, right? And that number is positive 1. Right there. What happened? Now, graphically speaking, let's look at the graphical representation of that. So look at all the x values here on the left side, and then all the corresponding y values here. It's approaching this point right here. And then here to this side, all the x values, it's approaching that point, which is 1. Right? Okay. Let's move on to the next example. So here's what I'm talking about earlier. Maybe you're thinking, why not plug in the number to x so that we'll be able to find the limit? Again, we can do that in some cases, but in some cases as well, we cannot just do that. So there are ways on how to find the limit of a function. And what we're doing right now is we're using table of values. So here, if you plug in that number 2 to x, this will be 2 minus 2, which is equal to 0. This will be undefined, right? This is going to be an undefined function. But let's try to use the table of values. By the way, this is negative x squared plus 4. I was not able to edit this. Okay. So I used 1.5, 1.8, 1.99, 1.999. Okay, so these numbers, imagine again a number line, they are approaching number 2. And then on this side of the table, that's decreasing from 2.8 to 2 down to 2.001. Again, we're not using number 2 here because if we plug in number 2, the entire function will be undefined. So if we plug in 1.5, 1.8, etc., etc., this will be the values. Okay, you may check out the answers here using your calculator. Now, if you use the numbers on the right side, 2.001, or 2.8, 2.5, etc., etc. Those numbers are approaching positive 2. They will be negative 4.001, negative 4.01, etc., etc. Now, as you can clearly see here, all you need to do is just look at these two numbers right here. And you know that in the middle of those two numbers is negative 4. So meaning the numbers here on the left and then on the right side, they are approaching negative 4. And negative 4 is the answer to the problem. That's the limit of this function as x approaches positive 2. Now let's look at this um, graphically. Okay, so here we go. So numbers on this side of the function, it's approaching positive 2 of x. And as you can see here, that means it's undefined. So if you plugged in number 2 and the whole function is going to be undefined, it doesn't necessarily mean that the function has no limit. So it's not going to reach negative 4, but it's approaching that value of y clearly. So it's going to be getting closer and closer and closer and closer to negative 4 as you plug in values of x from the left going to number 2, and then the number of x values from the right side to number 2. You plug in those numbers as you those numbers are getting closer and getting closer and getting closer to 2. It's going to get closer also to negative 4. It's not going to be equal to negative 4, by the way, because if you plug in that number 2, it will be undefined. Okay, so let's go to example number 3. Okay, so here is an example of a piecewise function. It says here that find the limit of f of x as x approaches 1 if f of x is equal to that x minus 2 where x is less than 1, and then x squared plus 1 where x is greater than or equal to positive 1. So 1 is in the middle. Okay, I choose these numbers. Again, you can pick any number and whatever number of numbers that you want. If you want 5, that will be fine, but here I have 4 numbers, so 0 0.5, 0 0.8, 0 0.99, 0 0.999. And then on this side, on the right side, we have 1.001, etc., etc. So if you plug in those numbers from the left, that will be the result. And then from the right side, this will be the result. So now let's take a look at the y values. So the question is, are they getting closer and closer to a certain number? So here it's getting closer and closer to, I think, negative 1, I believe, but this one is getting closer and closer to positive 2. So they're not getting closer and closer to a certain number. So if you see that kind of pattern, that means the limit does not exist. DNE does not exist. Okay, so let's see the graphical representation of this piecewise function. Here we go. That's obvious right here. Look at that. So the red one here is the x minus 2. So for 1, it's not defined because 1 is not less than 1, by the way. So if you look at that, 1 is not less than 1, but if we put 1, that would be negative 1. That's not going to be defined there. But it's on this side, it's going to reach negative 1. On this side of the function, which is the representation of x squared plus 1, the blue graph, that's going to be positive 2. So they don't really meet, or they're not getting closer and closer to a certain y value. That's why the limit of this function does not exist. All right, now maybe you're thinking, well, that means all piecewise function, the limit of that is going to be does not exist, undefined. Now let's see this example. Again, this is a piecewise function, so find the limit of f of x as x approaches negative 3, and this is our function. So again, I pick, imagine that negative 3 in the middle, pick those numbers from the left, and then pick numbers from the right side of that. So negative 3.2, negative 3.1, these are the numbers that I picked or I used. And then from the right side, from negative 2.5 to negative 2.99. Let's see the result. Here you go. So negative 7.8 to negative 7.999. And I think it's getting closer and closer to negative 8, right? Let's go to the next side of this table. Look at that, negative 7.9994. And I believe that is also getting closer and closer to negative 8, which means that our assumption a while ago we thought that maybe all piecewise functions, um, the limit is not going to exist. But here, look at that, it's negative 8. Let's see the graphical representation of this piecewise function. Look at that. So the red one is that negative x plus or minus 11 rather, negative x minus 11. So as that x values from the left side is getting closer and closer to negative 3, that is going to hit negative 8. Also, those numbers from the right side, they are getting closer and closer to that number negative 8. So here the answer is certainly negative 8. Okay? Now let's go to the last example. Okay, so here we have the limit of, or find the limit of x squared plus 6x plus 9 over x minus 1 as x approaches 1. Now here, just like I think in example number 3, I don't know if that's right. Um, when we do direct substitution, this is going to be undefined. Earlier, we noticed that if we use the table, we were able to find a function. But let's try in this particular function. Now let's use these values again. The whole idea is to find numbers from the left that are getting closer and closer to 1, and also from the right side that are getting closer and closer to 1. So if we plug in 0 0.5, 0 0.8 to 0 0.999 on the left side, let's see the numbers. That's negative 15,999. And then on the right side, that's going to be 16,008, or from 28.8 to 16,008. So I mean, look at the numbers. This is so big right here, and this one is so big, right? And it's approaching what number? That's the question. We don't know because that's big. And if you look at the numbers, negative 24.5, then it becomes negative 72.2, and then it becomes negative 1,592, and then it becomes negative 15,908. Those are big jumps among those numbers, also on the right side. So that's going to be a question mark, right? So if that's the case, the limit does not exist. Now let's check the graphical representation of this. There you go. So from the left side is going this. So that value is we don't know. From the right side is going this. That y value is we don't know. So clearly the limit of this function as x approaches 1 is does not exist. So that's it for today. I hope you learned something. Thank you for watching. Please do subscribe to my YouTube channel. Thank you and have a good night. Bye.